Good morning, all of you. In this lecture, uh, so this is a kind of manufacturing lecture. So you are going to learn during this modules the, all the metal processing. So metal manufacturing of these metals. What are them? Heat treatment process and casting process, cutting process. All those things you will learn during this course module. But before that, you have to learn about what is metal. What are the steel? So how you can classify the engineering metals. So these things briefly you have to learn before you're going to the processes, manufacturing processes, right? So in this lecture, we will discuss about metals in engineering. What are the metals mostly used in the manufacturing process or the engineering processes, right? So these are the outlines. First of all, you will learn about ferrous metals, and then uh, what are the ferrous metals, available properties of them, and then where you can use them, right? Okay, this is engineering metals. How you can classify these engineering metals, that's the first thing. So before that, so normally what the people are doing in the manufacturing workshop or the engineering workshop to produce something, a product or any things, they have at first they have to have materials, that mean raw materials. So that is called uh, engineering materials. So they have to have raw materials, and then they have to do some process. Using that process only, they are converting that engineering materials or the raw materials to the final product, right? So so in this process is called manufacturing process. So normally manufacturing process will be, or the manufacturing process is held in between the raw materials and the final product. So using this manufacturing process only, there are different types of process available. So using these processes, you are converting this raw material into your product or the final thing, right? And then, so these engineering materials have different properties. They have own properties. So they may have mechanical properties or the thermal properties, electrical properties, chemical properties. Likewise, they have a lot of properties, right? So if you want to sell, if you want to produce one product, then you have to decide which raw material you have to use to produce the product. Then how you can decide the raw material for suitable that product, you have to select using these properties, right? So if it's a just think about the hopper wires. So normally you are using that wires for your electrical circuits or in your home wiring system, okay? So you are producing that product. Then what you need to consider, it should have particular thermal properties and electrical properties should be important, right? So according to the properties, you have to select the raw material to produce your desired product, right? Then, okay, this one, engineering materials classification. That means how the engineering materials are classified. So first, engineering materials is there. How you can classify them? You can classify it to two different categories. One is metallic category, other one is not metallic category. Okay, so metallic category means, so under this category all are metals, and second categories are non-metals, right? So metallic, just now consider this metallic characteristics or the metallic materials. Then you can classify them further into two categories: ferrous materials and the non-ferrous materials, right? Ferrous materials mean they have iron as a main component, but in this category they don't have iron as a compound, right? Component. So then those materials who have the iron as a compound is called as ferrous materials, right? Then you can further classify it into two category, two section. One is steels, other one is cast iron. Then steels are plain carbon alloy. So likewise you can classify this ferrous material. So non-ferrous material means they don't have iron as a component. So these are the non-ferrous materials. Okay. In the other section, non-metallic materials, then that means they are not metals. So you can classify them as a two category: organic and inorganic. Organics are comes under here, like plastic, wood, paper. So those are the organic materials. Inorganic materials means ceramic, cement, minerals. So these are comes under the inorganic material. So if I ask in the question, so how engineering materials are classified, then you have to give the explanation or this diagram to that question. Okay. Okay. Next one, steel. Sorry, ferrous metal. So in this category, first engineering materials, then metallic, non-metallic, and the metallic, ferrous and non-ferrous. So first we will discuss about the ferrous metal. Ferrous metal is simply mean if anything has iron as their main component, they all are called as ferrous metals. So what's the difference between ferrous and non-ferrous? Ferrous metal has iron as their main component. Non-ferrous does not have, right? So example, pig iron, cast iron, steel, wrought iron, these are the examples of ferrous metals, right? Okay. How you can how you can collect these get the ferrous metal from the earth? These ferrous metals are not available as it is in the earth, right? So how it's available? It's available as in this form. It iron ore or the okay. Iron ore mean there are different iron ores available: hematite, magnetite, limonite, siderite. But these all have these ferrous metals, right? So these are available as it is in the earth. So if you want ferrous metal for your purpose, what you need to do, or what the manufacturing people are doing, they take this hematite or the magnetite from the earth, and then they are doing smelting process in the furnace using this iron ore plus coke and limestone. What they are doing, the some chemical process, or the for using the furnace they are doing smelting process, and then they are extract that ferrous metal from the iron ore. Then only they are using this ferrous metals for their purpose. So from here you have to mind it, ferrous metals are not available as it is in the earth. It's available as is this form. So another question, what's the difference between ferrous metals and the non-ferrous metals, or the how you can differentiate ferrous metal and non-ferrous metal? That's one question, right? So another question can be just list down uh, iron ores, or the four iron ores. Then you have to write them down: hematite, magnetite, limonite, siderite, right? So these are the color of these iron ores. So this one explains about amount of percentage of iron available in this iron ore, right? So here, just if I say 70 percentage of iron available in this iron ore, but when you consider the siderite, it has only 48 percentage of iron, right? So under the ferrous metal, these are the examples: pig iron, cast iron, steel, wrought iron. So here, pig iron. Pig iron means how you can obtain, you have to smelt the iron ores, right? Because iron ore is the one available in the earth. So using this iron ore, you have to extract the pig iron from the iron ore. So how you can extract the pig iron from the iron ore is, there there's the process that when you don't need at this moment. So there's a different types of furnaces available. So using that one kind of furnace, you have to blast this iron ores using chemical process, right? So using chemical process, you have to extract this pig iron from the iron ore. So this one pig iron also you can use as a raw material for your production, okay, um, of other ferrous metals. But in addition to this pig iron, it contains other constitution also. Just one thing: carbon, silicon, sulfur, phosphorus. Likewise, it has other constitutions. So it is called as impurities, right? So if I say example, uh, in addition to iron, what are the impurities available in the pig iron, right? Then you have to answer carbon, silicon, sulfur, phosphorus, manganese, right? So these are the impurities. This one also, these are the things also available in addition to the iron, right? Then other thing, you can classify, can be classified into three, right? How you can classify this pig iron? Because this pig iron has a constitution of the impurities. So one thing is carbon. Using this percentage amount of carbon, you can classify this pig iron into grey pig iron, white pig iron, modeled pig iron, right? So these three pig iron have different carbon percentage. According to the amount of carbon available in the pig iron, you can classify it into grey pig iron, white pig iron, modeled pig iron. Okay, so another question can be, what are the types of pig iron available? Or how you can classify the pig iron? One thing, grey pig iron, white pig iron, modeled pig iron. So another thing is, how you can classify pig iron as a grey, white, modeled. Then according to the amount of carbon available in the pig iron, right? Second one, cast iron. Cast iron is, it is an alloy of iron. alloy of iron mean? It has carbon, then iron. Other than that, it has impurities. What are them? Silicon, phosphorus are mostly available as impurities in the cast iron. Cast alloy mean if you are having ferrous metal here, if you are adding any non-ferrous metal or the other one or more than one non-ferrous metal to that iron, then it is called as alloy, right? Just think about gold. Gold is an alloy. You are adding the copper, right? Okay. Then how you can, as same as pig iron, how you can extract this cast iron from the iron ore? You have to use this furnace that's called as cupola. Then inside the furnace you have to add this coke, limestone and steel scraps. Then you have to do the remelting process or the remelting process of pig iron or the chemical processes. Then you can extract this iron. So this cast iron has properties. One thing, it's weak in tension. Weak in tension means it's a non-elastic or the brittle material, right? You cannot be able to use the elastic process. So it's very brittle material. So the tension is weak. So this cast iron has weak in tension. Has good casting characteristics. That mean other manufacturing process called casting process. You can use this casting process to the cast iron. High compressive strength. High compressive strength mean it resists being pushed together, right? So that means so it means compressive strength means it resists being pushed together. So then it has high wear resistance. So these words compressive strength, casting characteristic, tension, brittle material, machinability. So these 5 terms you have to have in mind, and then you have to add high low these words, and then for each and every metals. These 5 is casting characteristic, machinability, weldability, brittle material, wear resistant. These are the 5 things commonly available. Then according to the metal, you have, if we ask properties of cast iron or properties of other iron, then you have to write each. Low weak iron, low weak intention or the high weak intention. Likewise, so that's easy for your studies, right? So wear resistance mean if this cast iron has high wear resistance, so that means this cast iron is not easily damaged by friction or any use, right? So high wear resistant means this cast iron is not easily damaged by friction, right, or the use. So wear resistant means damaged by the friction or use, right? If it's a high wear resistant mean it is not easily damaged by friction or use. If it is very low wear resistant means, or if does not have wear resistant mean it can it can easily damaged by friction, right? So in here high wear resistance, that means it is not easily damaged by friction or use. Other one, machinability. Excellent machinability mean you can use any machining process to the cast iron. So these are the properties of cast iron. So here also uh, you can ask one question: how you can obtain this cast iron from the iron ore, right? So otherwise, briefly explain the cast iron. Or other question: what are the impurities available in the cast iron? Or just list down the properties of casting. These are the available questions here, right? Okay. In here, tensile strength of cast iron varies from 100 to 200 megapascal, right? Compressive strength, this one. Shear strength, 120. So this cast iron, you can classify this cast iron into grey cast iron, white cast iron, motlette, malleable, nodular, mehanite, alloy cast iron. So likewise, you can classify this cast iron into 7 major kinds cast iron, right? So normally basically this cast iron is present in the graphite form or the cementite form, right? So in the grey cast iron, here grey cast iron is one type of cast iron. This grey cast iron carbon is principally is in the graphite form, because we just discussed this cast iron can be in the graphite form or the cementite form, but this grey cast iron is in the graphite form, right? According to because this grey cast iron has carbon, iron. Other than this carbon and iron, it has some impurities, right? Non-ferrous metals, silicon, manganese, phosphorus, sulfur, right? Second thing, according to the percentage of carbon available or the silicon available or manganese available, properties of this grey cast iron is varied. Then if the properties of grey cast iron is varied, then application you can apply this grey cast iron to the different purposes, right? So main thing is here amount of this materials available in the grey cast iron. So see here carbon is, if the carbon amount is 2.5 to 3.8 percentage, properties of this grey cast iron is you can use this for the casting process there, because it can be easily casted, right? So then you can use this kind of material to the machine tool structure application, right? Silicon, if it's this amount, then it can be easily machined. So you can use it household appliances. So according to the amount of this percentage of this materials available, then properties of the grey cast iron is varied. Then according to that, you can use this grey cast iron for the different applications, right? Second one, this is white cast iron. White cast iron means grey cast iron in the graphite form, white cast iron in the cementite form. Here also it has these impurities plus carbon and iron, but percentage of this carbon is different from this one, right? So according to that, as I say earlier, properties properties are varied, and then you can use this for different applications, right? Okay, now the main or the important concept, steel. Steel also ferrous metal, right? Okay, what is steel? You all know, or you all heard about this word steel. Normally this steel is an alloy. Why you can say this is an alloy? Because instead of iron it has carbon, right? Carbon is a non-ferrous metal, so it has carbon. So if iron compound if iron compound has more than one non-ferrous metal, one or more than one non-ferrous metal, then you can call this as a alloy. So steel is an alloy because it has iron and carbon as a main components. Other than that, it has impurities, right? Okay, so technically percentage of this carbon present into the steels are normally 0.006 up to 2 percentage, or the 1.7 percentage. Up to 1.7 percentage is steel, called as steel. So as this percentage of carbon goes on increasing, see, this percentage of carbon goes on increasing, what will happen? Properties are going to change. What are them? There is an increase in the proportional stress there, or there is an increase in the ultimate tensile stress. So see, just if I explain, see, I'll roll here. Just here, think about this y-axis is percentage of carbon. Okay, so here percentage of carbon is increasing, right? You are increasing the amount of carbon in the steel. Then what happened? What will happen to the properties of this steel? What will happen? Proportional stress will be increased. Ultimate tensile stress will be increased, or the hardness increased, wear resistance increased, resilience increased. Resilience means ability of the material to absorb energy. So when it is deformed elastically, right? So the resilience means what's the ability of material to absorb energy when it's deformed elastically, right? So this will be happen when you increase the carbon percentage. Okay, now what will happen when you decrease the carbon percentage, or the sorry, what will happen when you increase the carbon percentage? These are increasing simultaneously, ductility also decreasing, right? So ductility, then formability, malleability, weldability. So these are the things will be changed. What are them? Ductility, malleability, formability, Other one, weldability. So when you increase the carbon percentage of the steel, ductility of the steel, malleability of the steel, formability of the steel, weldability of the steel will be decreased, right? So what are things will be increased? Wear resistance, hardness, resilience, ultimate uh, tensile strength, proportional stress, etc. Right? So these are things will be increased when you increase the percentage of carbon. Okay, ductility means, what do you mean by ductility is capacity to undergo a change of physical form without breaking, right? Ductile, so just this metal has this kind of ductility, so that means this metal has capacity to undergo a change of physical form, right? Change of physical form without breaking, right? Second one, malleability means it has capable of being shaped as by hammering or the pressing. So if you are doing hammering or if you are pressing, it has this kind of capable of being shaped. Right? So that is called as malleability. Formability is, as you know, weldability is also formability and weldability, you know the meaning. You can do the any forming process or you can do any welding processes. So these properties will be decreased when you increase the percentage of carbon. So these um, properties will be increased when you increase the percentage of carbon, right? Okay. So carbon plays an important key role for a particular application, right? Also, amount of carbon changes, the mechanical properties of this particular steel also changes. That's the conclusion, right? And other thing, amount of carbon is on the higher level, so that means that's of the 1.7 percentage. These steels are called as a cast iron, right? So at that particular points, carbon percentage is on 1.7 percentage. We can carry out only casting process, right? We cannot machine that particular part. We cannot do any kind of formability. We cannot do any kind of machinability. We cannot draw that particular steel into wires. Okay. So as a summary, this, if the steel contains maximum amount of carbon percentage 1.7, so it is called as a cast iron. So in that case, you can do it, or you can do the process only. That process is called cast iron process. Sorry, casting process. You cannot do any machining process, or you cannot do any forming process. You cannot do that mean you cannot machine that particular part, or you cannot do any formability. You cannot do machinability. You, and importantly, you cannot draw that particular steel into wires, right? So this carbon plays important key role while selecting particular material for an application, right? So if you want to, as I said earlier, so you are decided for a particular application, then using the carbon percentage only you can select particular material, because the properties of that steel will be changed according to the availability of percentage of carbon, right? So percentage of carbon influence the mechanical properties of steel and cast iron. That's a summary, right? This one I already taught you. Steel has carbon and iron. Other than that, it has impurities. So what are the impurities available on steel? Silicon, sulfur, manganese, phosphorus, right? These are the non-ferrous metals. So these are what will happen if you add this silicon, or the what will happen, or the what's the properties of this silicon. So it, if you add silicon to that steel, then it will prevent steel becoming porous, right? Or the sulfur increases the brittleness of steel. So that means if you increases the amount of this sulfur, then brittleness of this steel will be increased. If you increases the manganese, wear resistance, hardness, strength of this steel will be increased. Properties mean, sorry, phosphorus mean if you increases the phosphorus, it will induce mean increase the brittleness of in the steel, right? So these are the properties of this, or the effect of this impurities. So this can be uh, one question. Just explain the effect of this effect of the impurities on steel. That's one question. In another question, what are the impurities available on steel? Right? Or other, in other case, just explain the effect of manganese on steel. Then you have to explain this one. Likewise, question, uh, you can select lot of question using this effect of impurities on steel. So then again, you can classify the steel into further classification, that low carbon or the medium carbon, high carbon. So you can easily understand through this type name, because low carbon steel, medium carbon steel, high carbon steel, that means according or the depending on the carbon content the steel, it's classified as this. Then low carbon mean, and then it has low amount of carbon. Here medium amount of carbon, it has high carbon percentage, right? Very low amount dead carbon steel, that means it's very minor percentage of carbon available, or you can consider as not available, right? So this is classification of carbon steel, so steel according to the carbon content available on the steel, right? So you can ask, what's the different type of the classification of this carbon steel, right? Low carbon steel means it has uh, amount of carbon or the chemical composition of this carbon is around this one, right? 0.15 to 0.45, right? So guys, this steel is, very soft, and it can show a good amount of percentage elongation, right? So that is deformation, right? It can show the physical properties like the ductility. It's having a good malleability, good toughness, right? So these steels are not suitable for the heat treatment process. So we'll discuss the heat treatment process later. So these steels are not suitable for heat treatment process. So we can do halt working. You cannot use it for the heat treatment process, but you can do it. You can do the halt working. So this steels having a comparatively less strength, right, as that of the medium and high carbon steel. So that means when you compare to the medium and high carbon steel, this steel, low carbon steel, has less strength, right? So these particular steels are suitable to manufacture the structural steel parts, right? So this application where you can mostly use this low carbon steel, you can use it to the structural steel parts. So this kind of steel can show good amount of weldability. So you can use it in the welding process, right? Then according to the carbon percentage, carbon amount of carbon available, you can applications will be varied. So if you have this percentage of carbon, then you can use this low carbon steel to this kind of application. Likewise, you can use it to this kind of applications, right? Then medium carbon steel means these steels are stronger than previous low carbon steel, right? So it can be heated to improve the strength. So normally why we are doing the heat treatment process to improve the properties of that particular metal, right? So you, in the case of low carbon steel, you cannot use the heat treatment process, only you can do the halt working. But in this case, medium carbon steel, it can be heat treated to improve the strength, right? Then as I said earlier, so this is properties of that, and then according to percentage of carbon, applications are different. So these are the applications where you can use this kind of medium carbon steel. Then high carbon steel mean percentage of carbon available is higher than when you compare to the low carbon and medium carbon steel. So these are the strongest and hardest of all carbon steels, right? So when you compare with the other two, it's the strongest and hardest one. So it's a heat treatable. So you can do the heat treatment process, but it difficult to machine. So machinability is less, right? So this is the high carbon steel, and these are the applications of this high carbon steel. Then alloy steel. Alloy steel means, as we discussed earlier, we are adding some alloy elements to the ordinary steel, right? That is called as alloy steel. Why we are adding these alloying elements to the ordinary steel? To improve the properties of that particular ordinary steel, right? So as an example, what are the alloying elements? Nickel, manganese, silicon, chromium, right? So these alloying elements are used separately or in combination to get desired properties. That mean, so you can use to you can do so the add one alloying element or the more than one you can add, right? So each alloying elements improve the properties of such, so that toughness or the hardness messenability will be increased or the decrease according to the impurities or the alloying elements available to the ordinary steel, right? So then here, this is a, we just now discussed about the alloying elements. So then what will happen when you add this alloying elements to the ordinary steel? That means effect of these alloying elements in the steel, right? So these are the properties of this uh, nickel, also properties of this ordinary steel. That means if you add the nickel around like this percentage, what will happen to the properties? So tensile strength will be increased. So likewise, these are the properties effect, that mean effect of the properties of this alloying elements, right? Then next one, this one also important one, stainless steel, right? So stainless steel means this one also alloy. Why? Steel is a metal, ferrous metal, so it has iron. And then alloy mean it has chromium and nickel as a alloy, as a component, right? So just if I explain this, see this y-axis is corrosion rate, right? Corrosion rate. So this one is percentage of chromium, right? Now we will increase the amount of chromium in the stainless steel. What will happen to the corrosion rate? It goes like this. Why? When you increase the percentage of chromium in this stainless steel, corrosion rate will be decreasing. Decreasing means this material will have the strongest resistance for the corrosion. Corrosion rate will be decreased mean difficult, so less corrosion rate. It cannot be able to uh, it cannot just what can we say, just a corrosion rate is less means it has high or the great resistance for the this corrosion process, right? So this is the curve when you increase the percentage of chromium, or if you decrease the percentage of chromium, what will happen? Horizon rate is increasing, so it has less resistance for the horizon process, right? Just if I say steel means we are having this is a steel. Steel mean normally we are having iron and carbon, right? That is a normal steel, right? So what will happen? So you are exposing this steel to the atmosphere, right? What will happen to that? It will easily form iron oxide, Fe2O3, right? So that means when you exposing to this steel to the atmosphere, this material or the steel will easily get rust, right? Okay. In other hand, just see here, you are having steel here, so iron and carbon is available here, right? Iron and carbon is available here. So now you are adding chromium to this steel, right? That means chromium is available here. What will happen? Then now you are exposing this to the atmosphere. What will happen? Chromium also can react with oxygen. In the same time, iron also can react with oxygen, right? So in this case, this chromium and the iron are reacting with oxygen. This chromium and oxygen has strong reaction than the iron and oxygen. So that means this chromium and oxygen easily react with oxygen. So therefore it forms chromium oxide, right? That means it has faster reaction, so it easily forms. Therefore, this chromium oxide becomes as a cover or the layer of this surface of this steel. So then it does not get rust. That's the advantages of having this chromium to this stainless steel. Right, so that's the difference between if you have steel, what will happen to the steel when you expose to the atmosphere? What will happen to the chromium added stainless steel uh, when you exposing to the atmosphere? Okay, that's the advantage. Other thing, classification of stainless steel, Martin stick, stainless steel, ferritic, austenitic, stainless steel. Then you can use this for these applications. But these are the properties. But see, you are having ferritic stainless steel here. Ferritic structure, you are adding nickel like 5%. Then what will happen? You are forming another steel structure that is called duplex, right? Then again, if you add 8% of nickel, what will happen? You will get austenitic structure, right? So if you need to get the austenitic stainless steel structure, then you need to add nickel, right? So nickel mainly promote austenitic structure, right? So here again you can classify this as a high speed steel, stainless steel. That mean why they named it as a high speed steel, because you can use this kind of steels for the cutting tools making. Okay, so this type of cutting tools, uh, quickly operates. That means it has high speed. So therefore this kind of steels called as high speed steel. And again, if you add one or more alloying elements or the non-ferrous metal like tungsten, chromium, or the vanadium, like that, then you can classify this high-speed steel into further, right? So like molybdenum, cobalt, vanadium. That means if you add molybdenum to the high-speed steel, then it is called as molybdenum-based high-speed steel. If you add cobalt to that steel, it is called as cobalt-based steel. If you add vanadium to that steel, it is called as vanadium high-speed steel. Then that particular adding elements have different properties. According to that, high-speed steel properties will be varied. So then again you can use these particular steels to the different applications, right? These are the applications. As example, vanadium high-speed steel you can use to make the tools for the machining materials, right? So here, availability of steel in market. So just if you just go and check the market, there are steels available in the different shapes, but according to the shapes the name of that steel will be varied. So just see, if you can see this kind of steel, that is called that's the design of that is plate, so it's called as plate. This one L shape, so it's called as L shape or the angle. This one T shape, the T section. Shut shape, it says shut. So likewise the name of the steels will be different. And other thing, designation of steel in the market, they have different designation of the steel. You can see like this 4 numbers. So first to indicate type of material selected, if it is a carbon steel or the manganese steel or the nickel steel. According to that, the first two names, like first two numbers are 10 or the 11 or the 12 or 15. That mean you can think, okay, this is carbon steel material, right? So first two indicate type of material selected, and the last two indicate amount of carbon available in that particular steel. In the carbon steel, amount of carbon present in that particular steel, or the manganese steels likewise. Likewise, these are the notations, that mean steel designation system. So first two indicate type of material selected, last two indicate amount of carbon present in the steel, right? Okay, these are the brief, we have discussed about the ferrous metal, and this next class we'll discuss about the non-ferrous metal, other engine. This one we have discussed about the ferrous metal under the metallic ferrous metal only. So next class we'll discuss about the non-ferrous metal, right? Then before that, these are two questions for the USL study. You don't need to submit, or you don't need to uh, submit as activity or the assignment, but this is for your self study, right? First one, these are the different cast irons, so just compare with malleable, what's compare with their amount of carbon available or the properties and the applications. Compare these three cast irons. And other thing, these are different types of steels, just again compare them using properties and the applications. Just it's just put a table, 3 column, cast iron, malleable cast iron, ductile cast iron, broad cast iron, just like this. You can put a table, just put a 3 column. First one, composition, carbon composition, or the carbon and other impurities composition, properties and applications. Here, different cast irons. Likewise, put a table for this one also, and then do your self study, right? Okay.